The World Affairs Council of Greater Reading is the leading educational organization promoting understanding and enlightenment on global issues. Welcome back once again. My name is Mike. I'll be your host for the afternoon. This is going to be one of our Great Decisions series videos. So we'll be playing the video to get started here from the Foreign Policy Association, and then we'll introduce our speaker. I will remind everyone to keep yourselves muted during the meeting. We will have the opportunity for live Q&A with our speaker at the end of the presentation. So start entering your questions in the chat as they come up. If you want to join live to ask your question by video, if you're set up for that on your computer, then just let me know again in the chat and I'll coordinate getting you in. And without further ado, I will go ahead and get this video started for us. Let me just share the screen here. And I will see you again in 26 minutes.
I'm concerned with the world in which we're going to live tomorrow. A world in which a new machine, the digital computer, may be of even greater importance than the atomic bomb. Exciting and challenging, but doesn't it worry you?
New technologies are transforming our world. An automation revolution is making daily life easier for millions of consumers.
Hello Siri, what's the weather going to be today?
Alexa, what can I do about my migraine?
Hey Google, open YouTube on the living room TV.
Alexa, turn on bedroom light. It's that simple.
But it is also fueling international rivalries, displacing workers from farms and factories, and expanding the reach of authoritarian regimes. Great Decisions asks what the international community can do now to prepare for the looming challenges of the coming digital age.
Artificial intelligence, the global race for the new frontier. Next, on Great Decisions.
Great Decisions is produced by the Foreign Policy Association in association with Thomson Reuters. Funding for Great Decisions is provided by PricewaterhouseCoopers LLP and the Nelson B. Delavan Foundation.
By the end of this broadcast, Internet users around the world will have sent 9 million tweets, posted over 1 million photos to Instagram, and searched Google 102 million times. In their homes, they will have used smart speakers, smart fridges, smart thermostats, and even smart beds. In all, they will have generated a staggering 46 quadrillion bytes of new data.
Every day, billions of dollars change hands and countless decisions are made on the basis of our likes and dislikes.
All this data makes it possible for computer scientists to create programs that are capable of learning on their own. Those programs constitute artificial intelligence, or AI.
Computers mostly learn from access to large amounts of data. Data is the fuel for artificial intelligence, just like gasoline is the fuel for a car. The more gasoline, the farther the car can travel. The more data, the faster a computer can get to its conclusion of reasoning successfully.
I will generally define AI as technologies that rely on data. They're designed to find patterns in data, and based on an understanding of those patterns, to make predictions about the world.
Data is the lifeblood of these types of algorithms. You have to have a sufficient volume of training data to make them do the things that they do. Now, what's happened is over the last 3 decades, we've begun digitizing information at a scale never seen before.
Today, applications of AI are everywhere.
Voice recognition, machine translation, image recognition, diagnoses of certain diseases. Researchers are working on autonomous vehicles, robots that don't need to be explicitly programmed to perform certain tasks.
If you're watching a show on Netflix, you're going to see recommendations for what you might want to see next. That's based on machine learning. If you're driving an automobile that has a camera that may have a sensor when it identifies that there's a pedestrian crossing, that's artificial intelligence.
There's an enormous amount of AI going into what information you're being served up on your Twitter feed or your Facebook news feed. It's having a huge role in what's advertised to you. Already, we're starting to live in this AI world.
We turn now to Beijing, where a computer program developed by a subsidiary of Google has defeated the world's top-ranked player at the board game Go.
A spokesman for Facebook promised today that the platform will not take down a deepfake video of Mark Zuckerberg, which had been created by two artists in conjunction with an Israeli artificial intelligence startup.
Spectre showed me that whoever controls the data controls the future.
On the lighter side tonight, we bring you a story of facial recognition.
Scientists in Washington state have trained a computer to identify different species of salmon as they pass over Chief Joseph Dam en route to upstream spawning grounds of the Columbia River.
As the use of AI expands, workers are anxious about the prospect that new advances in automation could make many jobs obsolete.
You're already seeing automation sweeping the workforce, but if you look closely, it's not really eliminating jobs. What it's often doing is diminishing the value of work.
A lot of the developing countries depend on manufacturing. They produce our shoes, our t-shirts, where you have a lot of low-skilled laborers doing these things. However, if robots can be used in manufacturing, then these developing countries, these workers will lose out. And some countries might never industrialize at all.
Two countries stand at the forefront of the AI revolution: the United States and China.
I just got back from Beijing, and what I saw was an industry that was pretty much on par with the US. What singles China and the US out is that they can actually support these massive tech companies that are able to accrue the large-scale computational infrastructure and the massive amounts of data that is needed to create AI at scale.
The Chinese government has articulated in formal documents, in white paper strategies that they've been kind enough to publish, that it is their intent to supplant US dominance in 10 key technologically driven industries, including artificial intelligence.
With relations between Washington and Beijing growing tense, American experts have presented AI as a critical new battlefield.
We are engaged in an epic race for AI supremacy.
Big investments in AI by China and Europe already threaten U.S. dominance in this field.
Both our allies and potential adversaries are pursuing AI dominance.
By some accounts, China is investing $7 billion in AI through 2030.
Sometimes technological races end up being wars between civilizations. And so if we think now that there is really a contest between the Western democratic style and the Chinese, the consequences of the AI race could be consequences for the future of humanity.
Who's going to develop and lead the way in these technologies? And importantly, who's also going to try to shape rules around how they're used? And right now, we're not doing either. We're not at the cutting edge anymore. I think the Chinese are at least where we are. And we're certainly not trying to establish the rules under which these technologies are going to be used.
Some observers worry whether private American corporations can keep pace with Chinese companies that are backed by massive government spending on research and development.
If the United States doesn't figure out that we have to have an answer for the Huawei model, then China's going to do the same thing to us on AI that they did to us on 5G. That means the United States has to get over its reticence to have a true industrial policy, where the government and the private sector work together to try to develop new technologies.
We've been like, well, we got Google, we got Microsoft, we got Amazon, they'll fight this race. We got a lot of great engineers. No, they have their limits. Their budgets are big, but they're not like a nation-state budget.
We have this myth in the tech sector. It's the proverbial person, couple of people they're inventing in a garage or a dorm room, and then they go on and their companies become Microsoft or Google or Hewlett-Packard. There is an element of truth to that, but it misses something of fundamental importance. Since World War II, the federal government has funded basic scientific and technological research. typically through the large research universities in the nation. We're going to need this for AI. So when some people say we need more federal funding for AI, I think they're right.
We've been leaders in innovation traditionally because we've made investments in our education system. We've supported our universities and researchers in creating breakthrough technologies. And we need to make those investments if we want to continue to be leaders in innovation going forward.
Other experts question whether framing AI as a competition between China and the US might have dangerous consequences.
I've seen this narrative around China used a lot of times to kind of derail that discussion. Like, can't talk about ethics, can't talk about guardrails, can't talk about regulation, because if we do implement those things, China's gonna race ahead toward whatever this goal is, and we're going to lose. Maybe we don't want to be racing toward shoddy, exploitative, human rights violating, ubiquitous technologies. Maybe that's not a race we want to play, and maybe we want to do something different.
I'm very concerned about the tenor of the discussion surrounding technological innovation and how it's some kind of new realm of security competition between the US and China. This is already happening without much discussion or regard to the implications for both the global economy and the future of innovation.
Within China, technologies based on AI have made possible some alarming new methods of surveillance and social control.
We begin our coverage tonight in China's northwestern region of Xinjiang, where a data leak has revealed that the government is regularly tracking the whereabouts of some 2.6 million citizens.
Sources tell us that one social credit system now being tested in China scores citizens' reputations on a scale from 350 to 950, based on what they buy, where they go, and how they behave.
Breaking news tonight out of Hong Kong, where crowds are rallying in support of a student who was arrested for carrying 10 laser pointers, which have been used by protesters to sabotage security cameras and thwart police surveillance.
There was actually a recent study done that found that 8 out of the top 10 most surveilled cities in the world are in China. And when you think of a country of the population size of China, you can imagine how many cameras that actually is.
AI certainly has enabled surveillance. Instead of having humans watch hours and hours of video from CCTV cameras, you can use an algorithm to identify faces, to track movements.
We don't really know the future trajectory of autocracy in the 21st century. What we do know is that artificial intelligence and other technologies might, in fact, enable autocracy rather than challenge it.
When China exports new surveillance technologies to the developing world, those technologies might help fight crime and promote public safety, or they might enhance the power of authoritarian regimes.
China is interested in selling high-tech products. They're less concerned about how they're used, and they're willing to market them to whatever government happens to be in place in any given country.
Open Technology Fund found that Chinese internet technology for surveillance or censorship had been exported to 73 countries around the world across 5 continents. And it's important to keep in mind these are not only the autocrats. It is also, some cases, democracies, but a lot of countries that are, quote, partly free, and these technologies can really tip the balance.
Some governments, for example, in Uruguay, they're having all sorts of trouble at the moment with security. Crime is on the rise, and Uruguay really needs some surveillance systems, some CCTV and other systems to monitor things and ensure a degree of stability on the streets. And we'll likely use these technologies precisely for that purpose. But in other countries, those that happen to have more authoritarian tendencies, China is marketing these technologies differently. It's marketing them in a way that is promoting a population control.
Some commentators argue that fears over Chinese technology exports are overblown.
The notion that is being spread is that surveillance systems are a Chinese invention and a Chinese monopoly. Well, that is not the case. Surveillance systems are all over the world.
These are very mundane technologies, cameras, digital facial recognition technology, other kinds of internet filters and VPN systems, et cetera. And they're not controlled by governments, they're sold by commercial entities.
On the one hand, these are dual-use technologies, but on the other hand, they are being configured already in China in a politically repressive way. And that means that when they're exported, they're more likely to be used in that way.
By pouring resources into AI research, Chinese authorities have created an almost insatiable appetite for data.
CloudWalk is a Chinese AI firm that does facial recognition. They had only tested it in China. The Zimbabwean government bought it, got it for a lovely discount, and has used it for all sorts of repressive behavior.
And what Zimbabwe offered to China was basically its data. It offered faces, lots and lots of faces, that could be used to refine China's facial recognition algorithm.
The data-driven economy, and in particular AI, is going to require really good governance, and a lot of developing countries lack the funding, the willingness, and the ability to regulate this effectively.
The data arms race with China is driving calls for more open sharing of information.
As a nation, we in the United States are going to have to compete with China, even though we only have about a quarter of China's population. So over time, we should expect China to produce more data than the United States. We need a national strategy. We need a foreign policy strategy that will allow the US to connect with other like-minded nations.
More and more people have thought about building up walls here. Not just China, there are other countries around the world too who have wanted to build up walls around their networks. That basic architecture of the internet in terms of the free flow of data has been very, very important, and we need to preserve that.
The modern economy relies on the free flow of data around the world. But the global trade rules governing that flow were adopted when the internet was in its infancy.
The most comprehensive trade agreement in the world is the World Trade Organization. It contains trade agreements governing services, such as telecommunications, banking, that rely on cross-border data flows. But the WTO never mentions data. So they talk about computer services, but they don't talk about the internet because they were written before the internet became widely used.
There is the general agreement on trade and services. It hasn't really been enforced by the WTO or by parties to the WTO to govern data flows. But I think if you really took it seriously, it would, for example, say that China's blocking of Facebook or Wikipedia, parts of Google, is completely illegal under international trading rules. So there's a lot of potential for that to become a major thing. It just hasn't yet.
Recognizing the importance of data-driven technologies, both the Obama and Trump administrations have tried to include provisions in new trade deals that would keep the internet unrestricted.
Once approved by Congress, this new deal will be the most modern, up-to-date, and balanced trade agreement in the history of our country. Likewise, it will be the most advanced trade deal in the world with ambitious provisions on the digital economy.
Digital trade is really a new issue. The United States participated in writing a digital chapter for the first time in the Trans-Pacific Partnership, but we are not a signatory to that. There's work happening, again, to have a digital chapter in the new version of NAFTA, USMCA. That agreement would be the first.
I don't know that we'll necessarily need to have this addressed in every trade agreement. I think what we need to take more care to do is ensure that we're not pursuing domestic laws or policies that block the flow of data.
But the free flow of data also brings concerns about privacy. So far, the European Union has led the way in formulating regulations to protect users' privacy, particularly through the General Data Protection Regulation, or GDPR, of 2018.
We should celebrate the transformative work of the European institutions tasked with the successful implementation of the GDPR. It is time for the rest of the world including my home country, to follow your lead.
I think that the first thing we need to do in the United States is make sure that we're protecting consumer privacy, and then make sure that we're protecting the rights of consumers online. And if we're going to have a seat at the table internationally, we need to have domestic laws in place, and then make sure that we are exporting our views.
There is a challenge as we think about artificial intelligence and the protection of privacy. Namely, the tighter the privacy protection, the harder it may become to access large data sets for renewed research in AI. So how do we strike the balance? That's what people in Europe are starting to talk about. I think it's going to require a new wave of privacy protection in the 2020s.
It is true, I think, if you have strong privacy laws, you will restrict AIs from becoming good at certain things. Maybe if privacy laws prevent us collecting so much information about buying decisions, so much geared towards advertising, then maybe AI will start to develop approaches to other problems. And maybe it would move AI efforts towards other goals having less to do with human manipulation and behavioral control.
In the coming decade, Congress and the White House will enact laws that will help determine how AI develops in the U.S. and around the world. But experts are concerned that neither voters nor legislators have the sophisticated understanding of the challenges of AI necessary to make informed decisions.
How do you sustain a business model in which users don't pay for your service?
Senator, we run ads.
I see.
Well, if we're going to legislate on technology, then we need to get members of Congress up to speed on these issues. My background is in technology, so I consider myself one of those folks who can help educate my colleagues.
How does search work?
Is Twitter the same as what you do?
And next time you visit, if you would please bring some fiber because we don't have connectivity.
So it's not a little man sitting behind the curtain figuring out what we're going to show.
The problem with Congress isn't that they're idiots, it's they don't do anything. Congress is about as relevant as, I don't know, the local deli to this conversation. They talk a lot more, they occasionally will write some bills, but last time I checked, I haven't seen Congress pass any bill of any relevance to this.
I have a 7-year-old granddaughter who picked up her phone before the election, and up on there pops a picture of her grandfather. And I'm not going to say into the record what kind of language was used around that picture of her grandfather, but I'd ask you, how does that show up on a 7-year-old's iPhone who's playing a kid's game?
iPhone is made by a different company, and so, you know, I mean...
It might have been an Android. It was a hand-me-down of some kind.
The sort of framing of why are these senators so behind the times is a little annoying to me. We've lived through like 2 decades of mystification and obfuscation by the tech industry. The tech industry claimed to own the future, and anyone who dared to suggest that we might want to regulate it, that we might bend that future to norms that should be controlled by democratically elected governments was considered way out of line. How dare you hamper innovation? It's no excuse that people who are in charge don't do a little bit more reading. But I think this is something that does need to land back on tech's doorstep.
Experts and policymakers are deeply divided over how much to regulate companies working to develop AI technologies.
I do think that the government should play a role in regulating certainly the deployment of AI applications. It's not just enough for tech companies to regulate themselves.
Most people would prefer that the private sector and the public sector have an informal agreement and work collaboratively without overburdensome government regulation, because the reality is that government regulation is not agile, and it often constrains the type of innovation that's going to be necessary for national security going forward.
I would be more concerned at having a discussion with U.S. companies about where are you selling this artificial intelligence. That's the kind of discussion I think that should be taking place with our tech companies. And my suspicion is it's not happening.
Multinational institutions, such as the Organization for Economic Cooperation and Development, have put forth principles for the responsible use of AI. But there is concern that no tools exist to enforce these axioms.
All firms in those countries, when they utilize AI, when they utilize data, should follow ethical business practices that are agreed upon by many countries. And that's a good thing. And principles often lead to rules.
I don't have optimism that they will be implemented simply because we said they should be. I think it's going to take building different forms of power to sort of force the implementation of these principles. It will take things like waiving trade secrecy for some of these critical systems so that we can examine them and validate them.
Fundamentally, artificial intelligence empowers machines, computers, to make decisions that previously have only been made by human beings. When we think about it in those terms, I think we quickly recognize that one of the fundamental questions for all of us is, what kind of decisions do we want machines to make? If, in fact, we want the best of humanity to be reflected in these decisions made by machines, we need the companies that design this technology to be guided by clear ethical principles, rules, and oversight.
Because new technologies can so easily cross national borders, it will be imperative for countries to cooperate to meet the challenges those technologies create. World leaders once came together to construct a framework to manage the proliferation of nuclear technology. Time will tell whether they can do so again as the world enters the era of artificial intelligence.
Great Decisions is America's largest discussion program on global affairs. Discussion groups meet in community centers, libraries, places of worship, and homes across the country to discuss global issues with their community. Participants read the 8-topic briefing book, meet to discuss each topic, and complete a ballot, which shares their views with Congress. To start or join a discussion group in your community, visit fpa.org or call 1-800-477-5836. Great Decisions is produced by the Foreign Policy Association in association with Thomson Reuters. Funding for Great Decisions is provided by PricewaterhouseCoopers LLP and the Nelson B. Delavan Foundation.
As the codex run here, I will once again thank the Foreign Policy Association for making this spectacular content available to us. This is our 5th presentation as part of the Great Decision series, which the World Affairs Council of Greater Reading normally helps coordinate at great venues around Berks County as live events. Obviously, with the COVID-19 lockdowns, we're forced to do a lot of these events virtually, but we are extremely grateful to the Foreign Policy Association and also to you, our members, who have joined us, close to 40 of you here on the Zoom presentation live today, another half dozen or so on Facebook. Very grateful to be able to bring this content out. And with that, one final reminder that at the end of the presentation, we will have live Q&A with our speaker. So please start entering your questions into the chat. And I will help moderate those. If you want to be able to even jump on with your audio and video, again, just get my attention through the chat and I will coordinate. And without further ado, I will turn the meeting over to our president for the speaker introductions, Lynn Brown.
Thanks very much, Mike. Appreciate it. And welcome to everyone. Glad to have you with us today. Dr. Konak is a professor of information sciences and technology at Pennsylvania State University, Berks. He received his degrees in industrial engineering, BS from Yıldız Technical University in Turkey, MS from Bradley University, PhD from the University of Pittsburgh. Prior to his current position, he taught at Auburn University. He's also held visiting positions in teaching at Lehigh, Cornell, and the Chinese University of Hong Kong. His primary research interest is in the modeling, analysis, and optimization of complex systems using computational intelligence combined with techniques from probability and statistics and from operations research. He's been a principal investigator in sponsored projects from the National Science Foundation, the National Security Agency, and the U.S. Department of Labor and Venture Well. Dr. Konak, thanks for being with us today. We appreciate it.
Thank you very much. Thanks for the invitations. It is great to be here today. And I'm going to share my screen and let me know if you guys see that or not first. So you don't see my presentation yet.
There it is.
Zip. Everybody, can you hear me fine? Okay, and you can see the screen? Okay, thank you very much. Thanks again for inviting me for this talk today. I know it's challenging, to do these meetings over the internet, and we canceled like a couple of conferences this summer. So today, what I'm going to do is I'm going to talk about a little bit theory of the artificial intelligence, and I try to give you a understanding of how actually artificial intelligence works. So I'm an engineer by training, so mainly apply mathematician. So I don't have a lot of background in political issues surrounding the artificial intelligence, but at the end of my talk, I'll try to answer your questions regarding to that. So my talk main focuses today is just to inform you about how artificial intelligence actually works. Okay. So I just want to tell you a little bit my background. So I have been in Penn State Berks. I think now it's my 19th year. I don't count anymore. So it has been a long time. So typically this time of the year, I will be in Hong Kong teaching a course on engineering innovation at the Chinese University of Hong Kong. And this year, it was canceled like everything else. So when I'm in Hong Kong, I usually visit like China. I frequently go to Shenzhen. I visit like institutions like Institute of Advanced Technology, Shenzhen Research Institute, and give some talks there, mainly related to entrepreneurship and creative problem solving. But I have seen like last 10 years visiting there continuously how much artificial intelligence related research improve and develop in China. It has been like an amazing experience for me, and I think the video actually talks about this a little bit. So this is by the way, this is my class last year. So we have like this international class. My students are actually all over the world. They're coming from 20 different countries. So we have been doing this last 10 years in Hong Kong. It has been fun. So what we do in Penn State in terms of artificial intelligence, so we have like a students interest group. First of all, we come together, we discuss, we learn about what is going on in artificial intelligence, and we participate in competitions. Like one of them is like every year we compete in Neatly AI Challenge. Last year, Penn State Berks team got the 3rd place. So Resilient Resumes team, they created an artificial intelligence program that can actually read student resumes and make recommendations to them to improve their resumes. Okay, and we are going to have an artificial intelligence lab hopefully next year. We're going to call it Artificial Intelligence Modeling and Simulation Laboratory. And we have also like first 2 years of data science courses, and we have definitely first 2 years of computer science in Penn State Berks. And last year, we start offering a degree on cybersecurity analytics and operations. And this is mainly applications of statistics and artificial intelligence related to cybersecurity. Okay, and we have this degree since last year. Okay, so I want to start with the definition of the artificial intelligence. I mean, I think in the video you learned that artificial intelligence is like the programs that can perform tasks that are typically require human intelligence. And so what is the human intelligence? So what are the things that makes us intelligent? Okay, so Britannica defines artificial intelligence as mental quality that consists of abilities to learn from experience, adapt new situations, and understand and handle abstract concepts. So, how the computers are doing or how the artificial intelligence is doing in these tasks. when we say the artificial intelligence, everybody has like this idea of, intelligence robots, like in the movie Terminator, dominating the human civilization, take over the world, and enslaving the humans. Okay. Now, definitely, we are not. Artificial intelligence is not there, even close to those robots. Like, okay, they can learn from the experience. They actually excel on this. Okay, artificial intelligence right now is very good at learning from data. However, they are terrible at adapting new situations. Okay, so I can give like example from driving. Okay, so I taught my daughter how to drive. It took me like 2 weeks showing her how to drive. We went to Penn State Berks parking lot, and she was fine after 2 weeks. But look, autonomous vehicles, we have been trying to teach them how to drive for years and years, and they're not there yet. Okay, and I taught my daughter how to drive in the parking lot, but she can take that skill and apply to driving in a city, in a highway, in different conditions. But if I want to teach an autonomous car how to drive, I have to drive them, every single possible scenario so they can learn that actually. So basically, this artificial intelligence or intelligent machines are terrible at adapting to new situations. They can learn specialized tasks and they can excel on those tasks, but they cannot take their learning and apply to new areas. So that's kind of what is lacking right now. And definitely, there has been some improvement in understanding and handling abstract concepts. For example, we use Siri, so we use Echo. They can understand language, which is like an abstract concept. So there has been some improvement, but still we need to make a lot of improvements there. So artificial intelligence right now, it is really a hot topic, both in terms of research and in terms of the applications. So if you see this chart here, I don't know, you see my mouse when I point on? So this is the number of the research papers published in a topic called deep learning. So this is very popular right now, and it's part of an artificial intelligence. So if you see from 1986 to recently, so we see this exponential growth in artificial intelligence research. And I want to say, right now there is like almost 40,000 papers published every year on artificial intelligence, and 30% approximately comes from the United States, and other 30% or close to 30% is from China. So you see another chart here. This chart actually published by Gartner Research. So every year they publish this, what we call the hype cycle. So basically this is the technology that people are talking on the internet, technology that innovators are looking for to be promising in next 10 years or so. So if you look at these technologies, the top technologies are right now, the biggest expectations are biochips related to artificial intelligence platform as service, edge analytics, again, part of the artificial intelligence, edge AI, expandable AI. So really, we have like high expectations from artificial intelligence. So we are at the peak of that expectations or the hype right now in terms of the artificial intelligence. And I just want to briefly talk, how we can use artificial intelligence in our daily life. So this is actually like, we can consider this like in multiple layers, okay? Now, the lowest layer is the data layer. Like, artificial intelligence can explain us what happened. Like, for example, you take your car to a mechanic or a service today, what happens? They plug your car usually to a computer. Is that correct? The car, right now, the vehicles and the cars, they collect a lot of data. So there are these programs loaded on those computers which can analyze that data and look whether your car function as expected. So basically, this is what happened. It's an example of what happened. And if you have a problem or a failure, okay, artificial intelligence can tell us why that happened, because artificial intelligence is very good analyzing the data and looking at the patterns in the data. So this is the second level, or information and the knowledge level. So we can use artificial intelligence to create knowledge or analyze data to create information. And in the next level, the intelligence level, okay, so, you know, again, artificial intelligence, if you go back to our car example, can analyze that data and predict what kind of failures can happen, okay, can make recommendations. They says, okay, you need to change this, you need to change this part because the data doesn't make sense. I see some irregularities in your engine functioning, for example. So this is the intelligence part. So it can make predictions and predict what will happen. And it can provide insight. So this is like, what is the best that could happen? So the example of this, you know, we can collect this huge amount of data, for example, about car engine, and design an engine that could be more economical to function. So this is the insight part of it, and we already use that. And the final level is the change and the impact. So basically, we can use artificial intelligence to automate vehicles, isn't it? That this is the autonomous vehicle. So this is the layers that, you know, we can use artificial intelligence in different areas. So I just want to talk about briefly how artificial intelligence actually work. So you see different techniques here: expert system, intelligent agents, deep learning, neural networks, clustering. I mean, they're not important. I mean, these are the techniques of artificial intelligence that we use, but we can categorize all those techniques into two groups. The first one is the knowledge-driven, the other one is data-driven. So I'm going to explain how these two different approaches actually work in real life. So in the knowledge-driven approach, what we do is we actually create a program and step-by-step tell the program what to do in certain conditions, okay? So this is a tedious task. So you need to basically program that intelligence. In the data-driven approach, we really don't program anything. What we have is we have tons of data, and we look at the relationship in the data, okay? So we have some input, and the system gives you an output. So we try to find a relationship between this input and output. And so this is more like discovering rather than the programming. Okay, so I'm going to explain these two concepts using an example. The example that I'm going to use is a shape recognition. Okay, so the question that I'm asking is, how can write a computer program that can recognize shapes? And, you know, regardless of their orientations, surroundings, different colors, textures, you know, all kind of scenarios. So this is a very simple task for humans. Okay, I mean, you can teach this to 2 years old to learn the shapes, and they can do this perfectly. Okay, and it doesn't matter you tilt them, it doesn't matter they have different size. You know, we are able to categorize them and recognize the shapes. However, it is very difficult for computers to do this. And also, if you think about that, this is a fundamental problem. You know, if you are going to have an autonomous vehicle, you know, you want that autonomous vehicle try to recognize stop signs. That's kind of important, isn't it? So let's think about how the knowledge-based AI will do that. So knowledge-based AI will try to emulate the decision-making process of a human expert. So we will ask this question: how would an expert recognize the shapes? And then we try to simulate this in a computer program. Now, basically, an expert will solve this problem like that. Experts will have some kind of domain knowledge. You know, that knowledge is learned at school or by experience, and we categorize that knowledge as factual knowledge and procedural knowledge. And the factual knowledge examples are, circle has no corners, square aspect ratio is 1, oval has no side. These are just examples of the factual knowledge. And the procedural knowledge is like this. If, let's say, a shape X is an oval, and the shape's aspect ratio is 1, that means the ratio of the longer side to shorter side is 1, that shape is circle. So this is like kind of procedural knowledge that you learn at school or by experience. And then all humans have ability of reasoning. We have this inherent ability of creating new knowledge from the existing one. I mean, the example of this is, we know that apple is a fruit. We know that fruits are healthy. So automatically we deduct that apple should be a healthy food or healthy fruit. Okay, so, this is how an expert will solve a problem. So what I did here is I created like a simple computer program to solve this problem. So I have these facts here. I have a couple of procedural knowledge here, and then I can ask question to the system. Is oval a circle? Then this computer program will respond to me. Yeah, this is true. Is square a oval? Then it will false. But if you look at my computer program, you will not find this specific information inside the program. So this computer program will actually infer these answers by looking at the data that I provided to the computer program. So it behaves like an expert and help me answer those questions. So we use knowledge-driven AI in a lot of places. Like one of them is, the mortgage applications or loan applications. So if you apply for a loan, most likely you are dealing with an expert system, okay? Or medical diagnosis, we use a lot of it. Like computer support. Like if you call, your computer or, phone help desk, don't think that those people, they are experts. They really don't know anything. What they do is they punch in your answers to an expert system, and expert system tells them what questions they should be asking you next, and they try to help you using that expert system. So this is the knowledge-driven AI, and this knowledge-driven AI is not adequate, okay? Like I'm gonna change my problem a little bit. So think about this right now. You are trying to recognize or identify images in a fast-moving conveyor. Okay, let's say that you have a video camera here. This video camera is going to identify these images and categorize them, sort them in the next station. So our expert system will not work here because we need a human, even not an expert, we need a human to enter the data to the system. So what is my option? So what I'm going to do is I'm going to reformulate the problem. So I'm going to turn the problem to a mathematical function fitting problem. So consider that this camera takes pictures, and then in that pictures we have pixels. All digital images have pixels. And I know the background color of my conveyor, and then I'm going to look at the pixels, and if it is a conveyor color, I'm going to give them 0. If it is not, if it is shape color, I'm going to give it 1. So basically, I'm going to create this input. So this is basically a bunch of ones and zeros. And then I'm going to use, for square shapes, let's say 5, circles 0, rectangular 1. So I'm going to use like, numbers for my output as well. So my question is here that I'm asking, how can I find a mathematical function when I input those zeros and ones? It is going to give me a 5. So it's going to tell me, so this is a square, regardless of the orientation of the square or the size of the square. Okay, so this is what we call is the machine learning. Okay, so in machine learning, this is what we do. We collect tons of data, okay, millions of data. So in that data, we have like different types of input, different types of cases. We have different type of output. So we know this is a square. We know this is square, but a little bit tilted. This is a triangle. So we need to collect a lot of data. And then we have the machine learning algorithm, which tells me the structure of this function. So what I'm going to do is I'm going to present this input to my machine learning algorithm and look at the output, whether my machine learning algorithm is predicting well or not. If it is not predicting well, I'm going to change my function and try to train it to learn this data. So assume that I train my machine learning model, okay, and then how I'm going to use it. So then in my conveyor, let's say this new shape, which machine learning algorithm never seen before, but when I input this new shape, hopefully my model is going to predict me triangle because it has seen millions and millions of cases, and hopefully one of them will be close to this. Okay. So this is called machine learning. So basically machine learning, as discussed in the video, we use math and statistics. We look at the patterns in this massive amount of data and try to learn or memorize that data so we can use it for unexpected cases. So I'm going to take a couple of minutes, and I'm close to the end. I know I'm like 2 minutes past, but let me finish. I think we will still have time for questions. So, and a good example of data-driven AI is like image recognition, face recognition, or natural language processing, like Siri or Echo or Amazon Alexa. Autonomous vehicles use that. And another example that I want to give from Pennsylvania is like Geisinger study. So what they did is they look at the 400,000 heart patients and try to predict whether they are going to survive next year or not from their ACG results. Okay, so they have the actual data. They train this artificial intelligence to read the electrocardiograph graphs, and then that artificial intelligence actually able to beat the doctors in terms of the accuracy. So what are the problems of this data-driven AI? First of all, your data is very important, and it will amplify the prejudice or the biases in your data. I mean, the example that I can give you is from Amazon. Amazon tried to use AI to screen engineering applicants' resumes, and it turns out that it favored men over women over the years. So basically, the AI was very sexist. Okay, it turns out that they use a lot of male resumes to train the system. Again, the facial recognition systems, they have a hard time recognizing the woman faces, and they have a hard time recognizing the darker skinned people. Microsoft had this chatbot for Twitter to respond to users or to respond to memes. And over the time, this chatbot became racist and start rating like racist comments or sexually charged messages, and Microsoft had to change it. So another thing that kind of dangerous is we can trick these algorithms actually. I mean, if you look at here, I have a stop sign. Some researchers realized that if you put this like little stickers on the stop signs, autonomous vehicles, they cannot recognize the stop signs anymore. Okay, because they were not trained for those kind of situations. They were not trained for manipulated stop sign. And another example here is like I have a dog. So what I can do is I can put like a little bit noise in the background, and artificial intelligence will recognize it as an ostrich. For us, it looks like, again, a dog because we don't, we can filter out that noise, but the artificial intelligence cannot. So we call this kind of applications is the adversarial AI. Now, the next thing that I want to discuss is how AI can actually solve these ethical dilemmas. And, we have to answer this question. I mean, consider that we have this autonomous vehicle is, driving and it cannot stop. So on the road, there are like, maybe tens of people, and on the side, there is one person. So what kind of decision this autonomous vehicle make? Should it continue and kill 10 people, or should sacrifice one person to save the, those 10 people on the road? So how are we going to program these ethical situations in the artificial intelligence? So that's a big question, actually. Now, currently, what we have is the weak AI, which is designed to perform specific tasks, and they are very good at that. Now, our challenge is to create what we call it strong AI, which can match or outperform humans at general tasks. I mean, the best computers today even is not very close to the human capabilities, or they're not very close to the human brain. Although I have a little chart here, I'm not gonna go over this. Maybe we can discuss in the questions. Although our brain is very slow, almost millions of times slower than the computers, we can actually surpass computers in a lot of tasks, okay? So I'm gonna finish my final remarks. So we have seen a tremendous growth last 10 years. I think we will see more growth in the theory and the applications of the AI. To go further, I think what we need is like new computing paradigms. Okay, we are not really close to human level intelligence yet. And I agree with the video, we need a better governance of AI applications, and we need better governance of the data use. And I should tell you that we have a huge talent gap in computing, in computer science. We really need better programmers and better engineers in this area. So I'm going to finalize my presentation here. So it was hard for me to finish this in 20 minutes, but I think 27 minutes is good, I guess, Mike. Thank you.
Yeah, a very interesting presentation, Dr. Konak. Thank you for that. And I think, maybe we'll focus a little bit more on the social implications. We'll start to pass out the tests to everybody, though, on the programming side while we go through the rest of the Q&A here. But do please start entering your questions into chat, and I'll work those into the conversation. So growing up as part of Gen X, self-driving cars I always thought were a really interesting example, because the thought at the time was it was impractical because we'd have to retrofit all the roads. Now we find that they didn't actually retrofit the roads, they updated the intelligence of the cars. But at the same time, I think we heard you say that a lot of that is maybe more machine learning than artificial intelligence. So it sounds like the machine learning is very sophisticated, where the AI might be slightly less developed. So to reference the Terminator franchise, it feels like a big step from identifying 2D shapes to the birth of Skynet. What's the connection there?
Well, I just want to tell you, artificial intelligence, machine learning is a part of artificial intelligence. Okay, so artificial intelligence is an umbrella term that we use to describe all those technologies, and machine learning is a technique in artificial intelligence. The other being is the expert system. Well, I think we still have long years to go for autonomous vehicles. I'll tell you, and what we hear is, in terms of the research, we always hear the good research. We never hear about bad research about autonomous vehicles. Actually, they have like higher failure rate than which is really publicized. Okay, and you cannot really easily publish the bad research. And I think we have like 20 to 30 years maybe to go that fully autonomous vehicles on the roads.
And autonomous vehicles, I think, are something a lot of us are probably looking forward to. But if we reference back to the video, they talked a lot about the privacy concerns, the militarization of the technology. Hasn't the ship kind of already sailed on those things? There's not really a way to stop technology from advancing. And a lot of it is coming from either private industry or public educational institutions. So are we just kind of clinging to old models?
Well, I think that artificial intelligence, like any type of technology, and I think artificial intelligence more fluent than other technologies. Okay, it is hard to stop advancement here. Okay, I mean we can have the same concern for the weapons. I mean, weapons technology. A lot of countries sell weapons to other countries. A lot of countries sell weapons to take those dictatorships and all those kind of things. I think it's the same concern. I don't see the difference between the artificial intelligence technology and other type of technologies in terms of the export restrictions and so forth.
It's a different barrier to entry, though, isn't it? If you're talking about weapons, it requires resources, it requires manufacturing facilities. If you're talking about artificial intelligence, it's oversimplifying it to say all you need is a computer. But isn't it easier to adopt some of that because it's largely?
Yeah, I mean, definitely. It is. This is what I meant. It's more fluid. Okay, it can, it can easily adapt it. As long as you have good data, yes, that's kind of easy to adapt. But I think it's hard to stop that too. I think the video discussed, the countries needs to come together and some kind of regulate this. Like as the World Trade Organization is regulating that.
Can regulation work in a case like that? I mean, they say like information wants to be free, right? How much can you hold this under how much can you control this?
Well, I mean, yeah, it's a good question. I mean, I'm sure I'm not the best person to answer this. It is tough, okay? But Europe is trying to do this, okay? Europe is really trying to regulate how those technology companies is using that data. I mean, Google is using tons of data and collecting tons of data. And we don't know how they use that data. I mean, they say that they use it, for good purposes, but you don't know because that's kind of the black box. Sometimes we hear like some, bad examples. I mean, I can tell you, for example, Facebook was trying to use, the pictures that we are posting on Facebook to try to assess your health, okay, whether you're a healthy person or not a healthy person. Why they want to do that? They want to do that because they want to sell that information to, insurance companies. Okay, like in Facebook, for example, if you post something a lot about drinking or partying, okay, that's a red flag. You are a risk from the insurance company's perspective. Okay, so that is.
Okay. So on the we got a question in chat about what's the biggest risk of AI to society and world harmony. We talked about, in the video, we saw that facial recognition and mass surveillance to predict consumer or criminal behavior kind of sounds bad, but in your presentation, you talked about using AI to analyze EKG data to predict health overall. And I'll kind of add, so like, what are the biggest benefits and what are the biggest risks of AI to society and world economy?
Well, I think benefits are obvious. I mean, benefits are automation. We can automate the mundane tasks. We can really make significant progress in healthcare, manufacturing, transportation, and every segment of the economy. and we can expand the economy using artificial intelligence. I mean, there are a lot of risks. I mean, one of the risks I think I already mentioned. How fair these algorithms? Okay, there is like huge bias on those algorithms. Are we leaving some segment of the society? Are we discriminating against some part of the society? We can never know unless we study these algorithms and how they work. I mean, yes, I think this totalitarianism and the population control is a risk. I mean, last time I visited China, I had to, they took my pictures 10 times in every, everywhere, in the plane, leaving the plane, entering the plane, in the border 10 times, and you see the security cameras everywhere. Yes, that's a huge risk from the privacy perspective. But I think that's a decision that society has to make. And another discussion is, I think, are we gonna give up our works, like jobs? There is a risk there. I mean, they predict, for example, 4 to 7% of the low-skilled jobs will be affected from AI, like mainly clerical jobs, like scheduling, bookkeeping, those kind of jobs that require lower skill will be affected by artificial intelligence. On the other hand, they predict that it will create new jobs as well. Okay, so that's kind of, I think we will see like every technology, but every time we have the new technology, we have this discussion. When I was in college in 1980s, we assumed that, or we learned that, in 2000s, we wouldn't need any workers in factories, okay? But it's not the case right now. It never happened.
So you mentioned two things that we had some additional questions on. Bill Litvin in the chat asked, do we know why certain faces are easier to recognize than others, the women, people of color, etc.?
Okay, so that example was like kind of interesting because, who are the tech workers in Silicon Valley? They're mainly, young people and, white people. Okay, they just didn't test this for different type of population. So they are geeks. Okay, they test their algorithm, with the limited data set. They didn't train it with the broader data set, and they said, "Oh, that's good. Our algorithm is good. It works well." And but when it went to the real life, it didn't work well because they just exclude a lot of minorities.
So more than race or gender, it was just trained to identify geeks.
Yes. The original training set was biased. Okay.
Sure.
That was the case. So that's the reason. That's kind of important to have a very diversified workforce that can look at this kind of problems from different perspectives.
And we saw cases where early on with the iPhone face recognition, they talked about certain people couldn't unlock their phones. What other kind of real world implications or consequences have there been to that?
So one example, another thing is like, for example, they ignore makeup. Like women, they had hard time with the women. One reason was because they trained those algorithms without the makeup. When the woman makes makeup or with the glasses, for example, it makes a big difference. But over the time, when you collect more and more data, and when you see where it fails, you can go back and train that algorithm to compensate for those kind of scenarios. The worst thing about machine learning algorithms, we really don't know what's going on inside the algorithms. Okay, we feed them input, they give you output, they do a great job learning, and they do a great job connecting the input with the output, but we cannot really look at that algorithm and tell why the algorithm actually behaves in certain way. So we don't have that ability, and because they are so complex.
Yeah, that's interesting that you mentioned that we don't know what's happening inside those algorithms. One of the questions we got from John Fleming in chat was about new programming students getting started. Do they get started with ones and zeros, or are they using programs to create programs?
Okay, so I can answer this from Penn State or most of the U.S. Colleges. They start from the beginning of the programming. They start from 0-1s of programming. Okay, like this semester I teach a artificial intelligence class to the seniors, and usually in Penn State you can start taking those classes in the third or the late second year. But if you are interested in, like in Penn State Berks campus, you can work with the faculty in research. I know one of our faculty members there, Joe Mahoney. He does like research on artificial intelligence. So you can work with the students. I have like a couple of students, for example, working on research with me. So you can learn how to program those systems earlier in your career. But I think the taking classes are good, but if you want to learn machine learning or artificial intelligence, you need to do independent research. You need to do a project. Like my team last year, Resilient Resumes, when they start that project, they had zero knowledge of artificial intelligence. They had some programming, but they have basically zero knowledge. So along the road, they really learn how to program those systems. So they really create a functional application. I don't know that answered that question. Unless you are computer science, by the way, you don't learn those kind of programming languages.
Sure. This statement that we don't know what's happening inside the algorithms is maybe the most concerning thing about AI that I've heard, right? I think I've come to terms with the idea personally that privacy is kind of dead, being tracked all the time, but the benefits outweigh the risks. On the other hand, if we're relying on AI for security screenings in airports or to predict safety behavior in autonomous vehicles, isn't it concerning that what's the implication of saying we don't know what's happening inside these algorithms?
But, that's like kind of like a regular machine. I mean, you drive a car, you know that that's like kind of 99.5% reliable. Okay. I mean, you're not an expert on car. Okay, you understand.
The car is.
But today's car has a lot of algorithms in it. It has like almost like 30 to 40 microchips on them. Okay, and a mechanic even doesn't know, how those microchips control the car. These are like mainly black boxes. The technology is becoming like that, but we know that it works. 99.9% of the time, and the machine learning is the same way. We know that it works at a great percent of the time. That's what we know, and that's what we use.
All right, that's a good point. I'll take that for now. So let's go back to this idea. And again, if we have a couple more questions people want to get in through chat, we can. This can be our last call for questions. So go ahead and get those in. You mentioned about the workforce changes, and you kind of addressed it to say, at one point we thought we wouldn't need factory workers, now we still do. But that's not a linear progression, right? In this country, in this society, we know what it means to work and earn a living.
Yeah.
With increases of AI and machine learning and automation, less work, less labor will be required. So how do we start to think about what earning a living could look like in the future as this growth just continues to accelerate and accelerate?
Well, it is hard to predict, because we tell our students, we don't know what's going to happen. When you graduate in 4 years, we don't know what type of jobs you are going to get. Okay, but mainly what I think is in the future, when you learn things, you need to build the flexibility. You need to learn how to learn. You need to have that ability to learn new technologies, new skills. I think those kind of jobs will be more available. Okay, so it's not like trades mainly, okay, but more flexible types of jobs that demands adapting and learning new technologies. I think those kind of jobs will be more important in the future.
All right, I guess we'll all find out together how that plays out.
Yeah,
We'll
I mean,
try-
I'm a computer. I like computer programming. Okay, I'm like, usually people at my age, they don't program, but I still program, and it's a very important skill. And I believe, like, almost everybody should learn programming. It's just like a math. Okay, you learn math in high school. You should learn programming. It's not only you're going to be a programmer, but it's like kind of a part of broadening your horizon right now, because you need to understand how these technologies are working a little bit.
Sure. All right, so let's wrap this up on kind of a world affairs theme, right? You personally have experience working and teaching in China. China has come up many times as advancing their trade, advancing their economy, advancing their technology over our past several presentations. In this video, they talked about how China and the US are kind of the two big players. If you look at the relationship between the US and China, give us the good and bad. What's the greatest risk and what's the greatest opportunity? And you said you're not a political expert, so I get that, but
Yeah.
from kind of from the relationship between the countries, how do you see that?
Well, I mean, like most of the scientists, we believe that cooperation, collaboration, improves everything. Okay, and it improves the technology, improves the relationships. You are less likely to have like friction as you work together. And I think eventually both China and the United States benefited from this long relationship. Okay, I mean, in terms of technology, I think China plays smart a little bit. Okay, they really, they really don't want to be dominated in terms of the technology. They really, for example, didn't open up their markets unless you give some part of technology to them. Okay, they just don't want to be the only consumers of the technology. They just want to develop that technology, and this is true for artificial intelligence. This is true for any kind of technology. So that was their policy, and I think they have been successful in that policy right now. I mean, today 95% of the electronic supply chain, okay, is in China or go through China. So, it is impossible to make electronic components today without Chinese parts or somehow using the supply chain in Shenzhen. Okay, like Shenzhen, that city used to be a 30,000 fisherman town in 1985. Today it is 35 million metropolis, and this is one of the most modern cities I ever seen. Okay, it is very clean, it is very high tech. It is pretty amazing what they achieved last 30 years in terms of in terms of the technology, in terms of moving almost 600 million people out of poverty to the middle class. And this is the right of every country, to ensure that their citizens will be prosperous, well-being. So I don't think so. We can criticize China in that respect. Okay, I think we can criticize it not opening the markets. I think the U.S. has to push on this a lot more. Why Google cannot, sell their products, or why Microsoft and Facebook cannot sell their products in China. I think that's kind of issue. It's a big issue for U.S. companies. So that's what I can answer with my experience.
Excellent. All right. So John Fleming slipped in one last question. We'll finish, I'm guessing, on a positive note. Is the future bright, or should we be hiding in fear?
Well, I think the future is always bright. Okay, I think, I mean, if you look at the technology, we had these concerns all the time. We had these concerns in early 1900s when the automation is becoming dominant. Okay, I mean, people really concerned about their jobs. We have these concerns in 1960s, when the 70s, when the information technology is, growing. But over the time, if you look at it, all countries, we are more prosperous. Okay, if you look at the income levels, relative income levels, eventually technology improved it. It didn't reduce it. Okay. Now I think I understand from the U.S. part. I think U.S. lost a little bit the leadership in technology. Okay, or technology innovation. I think this is stressful for a lot of people, and I think Europe and China, they catch up in terms of the technology at some level, but U.S. is still the leader in a lot of the technologies today. So I mean, I think it is always positive. It is, as long as we use it for good purposes, as long as we collaborate, we cooperate, we negotiate in fair terms, I think it will be good.
I agree. And we'll wrap it up there. Thank you so much for your time, Dr. Konak.
Thank you.
I will turn the meeting back over to our president, Lynn Brown.
Okay, thanks, Mike. Dr. Konak, thank you so much for your fabulous presentation. Really appreciate it.
Thank you. Thank you.
And Mike, thank you again for your great skills in terms of emceeing. We appreciate that as well. Just a couple of things coming up, future programming over the next couple of weeks and over the summer. Coming up on the 24th of June, we'll have Dr. Chris Miller from Tufts University, who'll talk about Russia and the 2020 elections. What is Putin's game plan? On the 8th of July, we're going to have Dr. Victoria Hoy from Notre Dame University talking about recent developments in the China-Hong Kong relationship. And we're excited. We have also booked in August 5th at noon, all these at noon, former Ambassador John Herbst from the Atlantic Council will talk to us about diplomacy, certainly in Ukraine. He's the former ambassador to Ukraine, and key issues in Eurasia. So we're looking forward to those programs. Thank you very much for joining us today. We really appreciate it. And please, everybody, stay safe, and we'll see you next time.